Okay, so this is example 4C in 10.5, and we want to, what, like simplify maybe or something?
It says simplify each expression, express each answer in terms of positive exponents.
Here it is.
Assume that the variables represent only positive real numbers.
Okay, so we get to assume something, right? This says simplify, right? Which is going to be the same instructions basically for a lot of these, right? But I get to assume that x is positive. That's something so that I don't have to deal with, oh, well, there's domain issues, right? Cool. Okay, so on this, all right, I just need to simplify somehow. So what do I know about how exponents work?
You multiply, ain't that case? No?
Okay, yeah, but how do I multiply 3 halves of these together?
Switch them back to third root and then it's 4 raised to 5. Don't you have to switch them?
Okay, so
2 root, I'm sorry.
we could do this either way, right? We can either cube first and then take the square root, or we can square it and then cube, right? But really what I'm thinking here is I'm thinking, all right, this guy, 3 halves, right? That's a -1, and then there's times a 3 and times a half. You see that? 3 halves is these 3 things multiplied together. So these tell me to do things. The -1 in the exponent tells me to flip everything over. The 3 tells me to multiply it by itself 3 times. And then 1/2 tells me I have to take the square root. You can do that in whatever order. It doesn't matter, right? Multiplication doesn't care about order. So really, this is an exponent rule telling me that I don't really care what order this happens in. So pick one. I would advise towards square root first, probably. But you can flip it over first. That would be fine too. So I'm going to say, all right, I'm going to think about this as 16x to the 4th over 25 to the 1/2. And then all of that raised to the -3. You guys see that? This is using the exponent rule about multiplication, right? Okay, and then I'm going to say, okay, now this guy, I'm going to look at that 1/2 power there, and I'm going to think square root. So I'm going to take this guy, I'm going to rewrite as this is the square root of 16x to the 4th over 25 to the -3 power. Let's pull that.
Yeah.
Okay, so now what do you do? Yeah, how do I take the square root? Yeah, I should take the square roots of the pieces, right? Because square roots play nice with fractions, right? Yeah.
How does the half make you think
Ah, that was from the video. So the half makes me think about square roots because I have this rule, right? If I have a to the n raised to the m, right? I have this rule that I'm going to enforce that says I multiply those two things, right? And then I think, okay, if I have the square root of x and I square it, right? If x is positive, I just get x back out of this, right? You see that? So if I think about this as a power, I should multiply the powers. I better get 1. That tells me that really I could think about the square root as x to the 1/2 power. Cool? So these symbols are kind of interchangeable, right? So if I've got, really, the square root of stuff, I could think about that, oops, not as the square root of stuff, as the stuff to the 1/2 power. But equal signs go both ways, right? So here I've got stuff to a 1/2 power, I can think about that as the square root of this stuff. And then this is a symbol I know how to do.
So basically, the bottom is the square root, the bottom of the fraction.
The bottom of the
The
fraction tells you
denominator,
which
what-
root to
which-
take.
Okay, so if that was a 3, it would be
It'd be a
cube.
cube root, yep. If it was a 27, we'd be taking the 27th root. You guys cool with that? It's really just another way to write radicals. There's not actually very much in 10.5. It's just, oh, we're gonna write this symbol, root of stuff, as stuff to the 1/2 power. Cool? All right, this I know how to do. So let's see, what were we getting? What were you guys getting out of this square root?
2,
4x squared over 5. Cool.
yeah.
And then, oh yeah, I forgot, there's a -3 power on that.
Is that why you switched them over?
Sorry, say again.
You switched the top?
Okay, yeah, so I can think about this as 4x squared over 5 to the -1, all of that cubed.
Okay.
And then another little bit of fiddling with that rule tells me that the negative means that I should flip everything over. Okay, so I look at this guy and I think flip. Right, make sure that stuff's one fraction before you flip it over. If it's two fractions added together, flipping them over doesn't work. Right? You have to find a common bottom first. So flip this over, get 5 over 4x squared, and then I'm raising that to the what?
You,
Cube.
125
Okay, so I get 125 over,
64.
let's see, 4 times 4 is 16 times 4 is 64. And how many x's are there?
6.
Yeah, we're using the multiply rule, right?
Wait.
Because we're taking x squared cubed, right?
Where do you get the 6?
You have to, yeah, x squared and times that by 3 as well, you can't forget that.
Ah.
Yeah, really I'm thinking, okay, this
Okay.
is 5 cubed over 4 cubed x squared cubed, right? And then I'm using my multiplication rule. Or I'm thinking, okay, there were 2 x's multiplied together. Then I multiplied that thing by itself 3 times. That gives me 6 total. You guys cool with this? So we got this. Cool. All right, other things?